In the last few lectures, we've seen how we can use Venn diagrams to visually represent the information that's conveyed in A, E, I, or O propositions. And we've also seen how there are different ways in ordinary language of expressing such propositions. Sometimes such propositions are expressed even by sentences that use individuals' names and don't explicitly mention categories. Today, I want to talk a bit more about that. I want to talk about the various ways in which, in English at least, and in many other natural languages, we can represent the information conveyed by A, E, I, or O propositions using forms of language that we haven't yet discussed. So, let's consider some examples. So consider propositions of the form not all F's or G's. We haven't talked about not all before. Well, when you say not all F's or G's, what exactly are you saying? Usually, when you say not all F's or G's, what you mean to be saying is that there are some F's that are not G's. In short, what you mean to be saying when you say not all F's or G's is usually a proposition of the O form. So, how would you represent not all F's or G's? Well, all F's or G's, remember, would be represented by shading this out. That would be all F's or G's, but you're saying not all F's or G's. In other words, some F's are not G. So instead of shade there, what you would do is put an X right there. There's some F, something out there, that's not a G. It's outside the category of the G's. And for some examples, you might say, not all geniuses take Coursera courses. In other words, some geniuses don't take Coursera courses. Or you might say, not everything that Pat does is intended to annoy Chris. In other words, some of the things that Pat does, some of the things that fall into the category things that Pat does, are intended to annoy Chris. That is to say, they do fall into the category things that are intended to annoy Chris. So those are both examples of statements of the form not all F's or G's, and they're both equivalent to a statement of the form some F's are not G's. Now consider statements of the form all F's are not G's. Well, when you say something of the form all F's are not G's, that's usually intended to convey that no F's are G's. In other words, it's usually intended to convey a proposition of the E form. So when you say no F's are G's, how do you represent that? Well, you represent it by shading in the intersection of the F's and the G's. And that's just to say that all F's are not G's. Right? If there are any F's at all, they've got to be out here. They've got to be outside the category of the G's. Some examples of statements like that. All Nobel Prize winners are not alcoholics. Right? You're saying if there are any Nobel Prize winners, they're outside the category of the alcoholics. Everything that Pat does is not designed to achieve victory. Again, you're saying that whatever falls into the category of things that Pat does, it is outside the category of things designed to achieve victory. Right, so if this is the category of Pat's actions, and this is the category of things designed to achieve victory, then, when you say everything that Pat does is not designed to achieve victory, you're saying there's nothing in this intersection. Whatever Pat's actions are, they've got to be out here. Okay, finally, let's consider a statement of the form some F's are both G's and H's. If you say some F's are both G's and H's, what are you saying? Well, are you saying that there are some F's that are G's and some F's that are H's? Well, that's something you could say, of course. You could say some F's are G's and some F's are H's, right? You could say some men are tall and some men are short. But when you say some F's are both G's and H's, you're not saying that. You're saying that some F's are in this intersection of G's and H's, right? So some F's have got to be here. That's what you're saying when you say some F's are both G's and H's. Right? That's why you couldn't say, at least you couldn't truthfully say, some men are both tall and short, right? There's no man who is both tall and short. But you could say there are some men who are both wealthy and happy. They're a man who is wealthy and who is happy. Other examples, some philosophers are both robotic and monotone. Right? It's not just that there are some philosophers who are robotic and some philosophers who are monotone. There are actually some philosophers who are both robotic and monotone. Some of the things that Pat does are both intended to amuse and to provoke. Right? It's not just that some of the things she does are intended to amuse and some of the things she does are intended to provoke. It's that some of the things she does are intended to do both amuse and to provoke. So, if these are Pat's actions, right here, and this is the category of things intended to amuse, and this is the category of things intended to provoke, then this last statement, some of the things that Pat does are both intended to amuse and to provoke, is saying that some of Pat's actions fall into this area right here, this intersection of things designed to amuse and things designed to provoke. But of course, since they're Pat's actions, they have to fall into this portion of the area, right here. Okay, I hope I've given you a sense of the various ways in which ordinary language can express ideas that we can represent visually using Venn diagrams.